My name is Jessica Webster, and I'm in Monday Lab 1. In this lab, I will be comparing observed and predicted data based on my observation, a rolling water bottle, moving at a constant velocity. In this lab, I use programs Python, Tracker, and Excel to help me analyze my data. I also assumed that the air resistance and friction forces were negligible, my object was moving at a constant velocity, and therefore my net force equals 0. This is my video in Tracker. I made the axis so the bottle would begin motion at the origin. Also, the direction of the motion is positive x. For my water bottle, I made the mass and the diameter an approximation from a 20-ounce soda bottle. Also, as you can see at the right, the bottle is indeed moving in the positive x direction at a constant velocity.
As a recap, my initial time began as soon as the hand was no longer a force on the water bottle. The diameter of my water bottle was approximated from a 20-ounce soda bottle, which was 0.07 meters. The mass of my full water bottle was 700 milliliters, or 0.7 kilograms, and the axes were changed to make the motion in a positive x direction. Now I'm going to see if my prediction was good by making a computational model using Python. Here I initialized my code using my water bottle's data. As you can see, I made the mass 0.7 kilograms, and I also updated my water bottle's position and velocity using data from Tracker. As you can also see, I set my time step equal to 0.042 seconds, so it would exactly mirror my data from Tracker. In my while loop, I made sure the code would keep looping as long as time was less than my final time of 1.252 seconds. I also made sure that Newton's second law was in my code. As you can see, there are two vectors that are going to be continuously updated, although the velocity vector will remain constant because the net force equals 0. The only vector really being changed will be the position vector, because the velocity will be continually added to the initial position. When my program runs, you'll see the bottle moving in the positive x direction and the velocity is constant. Now for my graph, you can see the blue line is the observed data, and the red line is the predicted data. Therefore, we can say that my lab was a pretty good prediction. But what if the water bottle was actually moving in the negative x direction instead of the positive x direction? I went back into my Python code, and I updated the initial conditions for the position and velocity and changed the direction. So now you will see that it's actually starting in the negative x direction. The while loop is just the same. Now the bottle moves in the negative x direction. The velocity has the same magnitude but a different direction. What does it all mean though? My main assumption is that the net force is 0. After the hand exerts the initial force, there is no force to unbalance the movement of the water bottle. This means the total pushes and the pulls of the water bottle equal 0, which makes the velocity constant. If there was a force in the positive direction, the water bottle would speed up. If the force was in the negative direction, the water bottle would slow down. Thank you so much.